Hi and welcome to John's Maths Book. In this video, we're going to be looking at techniques for finding the limits of functions. If you like the video, then please hit the like button and I'd be delighted and honored if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. So let's look at our first method for finding limits. This is called the substitution method. We should try the substitution method first whenever we're trying to find the limit of a function. So we want to find the limit as x approaches 1 of the function x to the power of 4 plus x squared minus 1 divided by x squared plus 5. Using the substitution method, we can substitute the value of 1, that is the value that x tends towards, into the function. So let's do that. So when we substitute 1 into the function, we have 1 to the power of 4 plus 1 squared minus 1 divided by 1 squared plus 5. If we evaluate this, we get 1 plus 1 minus 1 divided by 1 plus 5, and that all equates to 1 divided by 6, or 1/6. So using the substitution method again, let's try and find the limit as x approaches 2 of x plus 2 divided by x squared plus 5x plus 6. So we need to substitute the value of 2 into our function. So when we do this, we get 2 plus 2 in the numerator divided by 2 to the power of 2 plus 5 times 2 plus 6. And this evaluates to 4 divided by 4 plus 10 plus 6, which is 4 divided by 20, which is 1/5. If we now look at this limit as x approaches minus 3 of x squared minus 9 divided by x plus 3, we get minus 3 squared minus 9 divided by minus 3 plus 3, which equals 9 minus 9 divided by minus 3 plus 3. Now, as you can see, we end up with 0 divided by 0. Now, anything divided by 0 is undefined. So this method won't work in this instance. So in this case, we can try the factor method. Using this method, we can factorize the numerator in this case. And as you can see, we get x plus 3 multiplied by x minus 3. Now the x plus 3 in the numerator and the denominator can be eliminated. So then we're left with a limit as x tends to minus 3 of x minus 3. If we now substitute our value of x minus 3 into x minus 3, we get minus 3 minus 3, which is equal to minus 6. So as the limit of the function tends to minus 3, the limit is minus 6. So now let's look at another example of where we can use the factor method. So let's try and find the limit as x tends to 5 of 2x squared minus 7x minus 15 divided by x minus 5. So before we do that, we need to check that we can't use the substitution method. So as you can see, if we plug x equals 5 into the denominator, we get 5 minus 5, which is a division by 0 and therefore undefined. So we can't use the substitution method in this case. So if we now factorize the numerator, we can see that the limit where x tends to 5, we have a factor of 2x plus 3 multiplied by a factor of x minus 5. As you can see, the factor of x minus 5 in the numerator cancels out with the factor x minus 5 in the denominator, which leaves 2x plus 3. So if we now substitute 5 in for x, we get 2 times 5 plus 3, which equals 13. So as x tends to 5, the limit is 13. So we look at one final method for finding limits. It's called the conjugate method, and it's useful if you have a radical in your limit, where you can multiply the numerator and the denominator by the conjugate of the expression. So let's try and find the limit here, where x tends to 5 of the square root of x plus 11 minus 4 divided by x minus 5. As usual, we'll try the substitution method first. And as you can see, when we plug 5 into the denominator, we get 5 minus 5, which is 0. So we have a division by 0, which will be undefined. So we can't use the substitution method in this case. So using the conjugate method, we can multiply the numerator by its conjugate, and then also multiply the denominator by that conjugate. So the numerator has the square root of x plus 11 minus 4. So the conjugate of that is x plus 11, which is a square root, plus 4. So multiplying numerator and denominator by the conjugate, we get this. If we now expand out the numerator, you'll see that two of the terms cancel each other out. One's a positive and one's a negative. And we're left with, in the numerator, x minus 5, which cancels out with x minus 5 in the denominator, which leaves 1 divided by the square root of x plus 11 plus 4. If we now substitute our value of x equals 5 into this expression, we get 1 divided by the square root of 16 plus 4, which is 1 divided by 4 plus 4, which is 1/8. So the limit as x tends to 5 is equal to 1/8. Now let's look at another example of the conjugate method. So let's try and find the limit as x tends towards minus 2 of x plus 2 divided by the square root of x plus 6 minus 2. So once again, before we start, we can try the substitution method just to see if it works, as that's the easiest method to use. Now, if we plug in x equals minus 2 into the denominator, you can see we get a division by 0. So given that the substitution method won't work, we can once again try the conjugate method because we have a radical in the denominator. So in the denominator we have the square root of x plus 6 minus 2. So the conjugate of that is the square root of x plus 6 plus 2. So we multiply both numerator and denominator by this. If we now expand the denominator, we see that two terms cancel out, thus simplifying the denominator. We're then left with a common term in the numerator and denominator, which cancels out. The whole expression then simplifies to finding the limit as x tends to minus 2 of the square root of x plus 6 plus 2. So if we now substitute the value of minus 2 in for x, we get the square root of minus 2 plus 6, which is the square root of 4, plus 2. So that simplifies to 2 plus 2, and finally we get our limit of 4. Sometimes we try and find the limit of functions, and they just do not exist. So to finish off, let's look at some examples of some functions where limits do not exist. So let's first look at trying to find the limit as x tends towards 0 of 1 divided by x. In this case, if we substitute 0 in for x, we get a division by 0, or we get 1 divided by 0. And also in this case, we can't simplify it in any way in order to find the limit. So in this case, the limit as x tends to 0 of 1 divided by x does not exist. If we look at a similar example, where we try and find the limit as x tends to 0 of 1 divided by x cubed, we see if we substitute the value of 0 in for x, we again get 1 divided by 0, which again is undefined, and we cannot simplify this expression any further in order to find the limit. And finally, if we look at trying to find the limit as x tends to 2 of the square root of 2 minus 6x, if we substitute the value of 2 in for x, we get the square root of minus 10. Now we cannot find the limit of the square root of a negative number.